We're going to move on to the Y-axis gantries. So I'm just going to put this off to the side for now. Maybe I'll put it to the front here, so you can kind of check it out. And we're going to move on to the next page. This is going to be, as I mentioned, the Y-axis is the one with the two rails going in and out. And you're going to notice that these steps are going to have a lot of similarities to the steps you just did. We're going to be putting on wheels. We're going to be putting on robot heads or anti-backlash nuts. We're going to be screwing in lead screws. It's going to be a great time. And yeah, once again, continuing to use these bolts here and starting with the fixed wheels. Actually, I'll grab both of these. And these you just assemble them mirrored, so I just tend to sit them down on the table in a mirrored fashion. And that way I know that I don't assemble the same thing twice. Oh yeah, sorry, I don't need the bolts because I've got the pre-made assemblies. So once again, we're just gonna wiggle these in from the top side. Hand thread on the nuts from the underside. And then go in with the Allen key, the M5 Allen key, and the wrench afterwards to get it all nice and tight. And once we've got these guys put together, you're going to actually see how they slide onto the rails. And then we're going to be putting the rail together after that for the Y-axis. It was a fun challenge for me to design the plates, these plates and these plates, because there's kind of a... There's obviously the function that they need to serve, and that function needs to be made very clear. You know, I'm not going to stick a bunch of holes on this plate so that you guys get really confused about what's going on. But also sometimes the strength of material is surprising, and I was worried if I put too many holes in here, even though it would still be plenty strong, that you guys would think it's kind of weak. So all that is to say, I took away the material where I thought I could take it away while still making it look real tough. And what that means is that these are still more over-engineered than they really need to be. But they look good, so that's a pro. I'm going to grab the bag of eccentric nuts, the offset nuts, because we're going to be using the rest of these at this step. And any ones you don't use, you can set aside. And this time, if you look at the close-up, that follows, so there will be the picture showing them going in, and there will be a picture that follows it. That'll show the close-up showing that the offset needs to be going up this time. And the reason it's going up is because on this guy, the offset nuts were on the bottom, so then we wanted the nut to be facing the bottom. And that's because it opens up the space between the wheels so that the wheels are the furthest away. But here, the nuts are on the top, so we want the offset to be on the top so that we're still opening the wheels as far as possible. Is my nut on? Yeah, my mic's all right. Okay. And once again, you're putting in the offset nut first this time, and then screwing in the wheel from above, just hand tighten. Yeah, so about the plates again, the other reason why it's good to remove material is because obviously we don't want to use excess material where it's not needed, but also we don't want if we're trying to put this whole machine into one package and then we make the package weigh, a metric ton, none of the UPS or Canada Post or whoever else, they're not going to show up at our door to pick up our machines. They're going to say, oh, those guys again? Their boxes weigh a ton. I'm not going to go there. Someone else go there. And then, no one's going to come pick up our machines. So, or our own packers, they're going to be like, we're going to have to pay to get them massages every day because they're just, they just can't take it. Yeah, so we don't want to do any of that sort of stuff. You can check if you want against like the weight of our machine against other machines. Obviously, there's always the argument of rigidity comes with weight, which I totally see. Like if you're trying to stop vibration and you're trying to have something just stay in place, you're just going to make it weigh a whole bunch, right? But to be honest, I'm not sure how familiar you guys are with kind of diminishing returns, but basically what happens in the world of manufacturing, which a CNC router is a manufacturing tool. I'll pause this for a sec. I'm at the nut installation stage, so I'm just following the pictures still. I'm putting in the bolts from the underside, the robot heads in from the top side, and just screwing this through. Anyway, back to manufacturing, because I've done a lot of my area of interest as far as mechanical engineer is manufacturing and designing mechanical parts. But anyway, you basically have these diminishing returns, and what that means is that, and this is just a true fact, basically. For every magnitude of increase in accuracy, it's usually going to come with, at the very least, a magnitude of increase in price. So here's a really simple example. Like you could have a measuring tape, right? A measuring tape, if you just buy it from any, hardware store, you can buy it for a couple bucks, right? And that measuring tape is going to be accurate to probably like 1 or 2 millimeters. It depends on, oh right, I'm not supposed to tighten these all the way down. Keep them loose. It depends on the measuring tape you buy, and also it depends on how far of a distance you're measuring. But, like let's say you're measuring things that are a couple meters long. You're going to be off by maybe just a couple millimeters max. Depending on how cheap you're going, like bottom of the barrel measuring tapes, which is pretty good value. But as soon as you start saying to yourself, well, I want to measure something to an accuracy better than a millimeter, well, what do you have to pick up now? You have to pick up calipers, right? Calipers you can still get for, kind of cheap. It depends where you get them. There's some Chinese calipers that you can find for really good prices sometimes, like less than $10. So, that's a pretty cool advancement in technology. But now, let's say you want to measure, like I would say most Chinese calipers and other calipers, I would expect them to be accurate to, let's say, 0.1, 0.2 millimeters. If you're wanting to buy, high-end calipers, that you can trust more and are actual calibrated tools, you're now looking at spending easily, over $100 on them, like some Me Too Toyos or something like that. And then if we take it another step further and you say, well, calipers aren't even enough. I need even more accuracy. Like get me below, 0.01 or what have you. Now you're looking at picking up like a whole granite counter or surface plate, and you have to have a guy coming in to calibrate that every once in a while to make sure it's accurate. And then you've got to have your granite measuring tools on the surface plate, and you got to make sure that you're upkeeping that. And you're sinking like hundreds and hundreds, thousands of dollars into this. This is escalated very quickly in terms of price, right? But the amount of extra accuracy you're getting is, in the grand scheme of things, not that much. I mean, it is a lot depending on what you have to use it for, obviously. But, let's keep the topic of conversation just to hobby individuals like you are, and like even myself, I am. You know, we're not going to be checking for atom thicknesses on things, right? And so basically what this all comes back down to, I finished the nut step, so I'll just stop for another second here. Actually, I'll finish what I'm saying, and then I'll move on to the next step. Yeah, basically what this all ends up coming down to is like, if it applies to adding mass and rigidity and all that other stuff. You add all the other stuff and that's great, but like the improvements that you guys would see is very minor, right? And that's why a professional CNC can cost, you know, over $100,000, and we can make our hobby CNC cost, you know, $1,000 or like, you know, $1,500, $1,800, depending on whatever currency you're using. But that's the great thing about it. And so, you know, we made sure to kind of pick our battles basically when we're putting this machine together, is, you know, how can we make sure it's an accurate enough machine for hobby use and nothing more? Because anything more than that, you're kind of, as I explained, you're kind of not getting as much out of it. We're going to set these aside because we're going to be putting these feet together. I will say, by the way, that because of the setup, you could make something on a much cheaper CNC that the LongMill could also make. But the reason there is a difference there is because we have opted to make it rigid enough so that we feel like you can use it at a true hobby level. A lot of these smaller, cheaper machines are still fine, but they take a much longer to cut things out because they're going to bend around a little bit more. Our machine, we try to make it so that it's like, you can set it up, you can run it reasonably quickly, you know. It's like a usable machine, you know. Anyway, this is a crazy tangent. Onto the feet. So we've now hit the stage of assembly, and I'm just going to organize this stuff off here. And the eccentric nuts I'm going to set to the side. And I think the regular hex nuts I don't need to use anymore as well, so I'm going to set those to the side. Oh no, actually, no, I do need them. But we've reached the part of the assembly where we're going to open up this yellow bag of hardware. As you can see, the green bag is depreciated to, you know, just a couple things here. So what we're going to be finding in this new bag here, when you open it up, is T-nuts. It'll be in a bag called T-nuts, M5 T-nuts. And you can leave the rest of the stuff in the bag if you want. For now, I'm going to spread it out in the corner over here so that it's separated from my green hardware stuff. And then that way you guys can know, am I grabbing from green or am I grabbing from yellow? But it'll also be written in the manual. It'll say when the hardware is in green or when the hardware is in yellow. So basically for these feet, you're going to be taking these same bolts we've been using the whole time. And if you flip the foot upside down, you should be able to fit the bolt in from the underside. I'm just going to use my M5 Allen key to push it all the way through. And then when it sticks out the top here, you're just going to take one of these nuts and screw it on from the top. You only need 4 of these at this stage, 1 for each foot. And I'm going to leave these over here because these were from the yellow bag. So the T-nuts, they have a top, like they kind of have, they're directional, just like the nylock nuts are directional. And so the thinner part, you want it to face down into the foot. And you can see from the side view we offer on the computer that the shape of it, so that you know how to orient it. So basically, you're just going to want to screw, make like 1 or 2 turns, and that should be all you need to do. And then we're just going to do this for each of the feet. Okay, now is where things start to get a little big. So I'm going to just stand up here and put some of this other stuff off to the side, like the feet here. And the hardware I'll leave over here, but I'm just going to push it close to me. I'm going to bring these close to me as well. We're going to be taking out the Y-axis rails. And I'm just going to lay them out where they go when you're actually putting your machine together. Now, when I assemble this machine, I'm going to be assembling it so that it faces towards me, so that I'm, in the perspective of the instructions. So from your perspective, it might seem a little bit skewed or backwards or whatever, but just bear that in mind. So when I'm working on the left side here, it's going to be my left side and not your left side. Or maybe we'll just flip this footage or something like that. I don't know. In any case, the steps I'm about to do, for the most part, are all mirrored from the left side to the right side. So it doesn't really matter which side you're looking at. If I do my left and you do your right, it'll all work out. Basically what we're going to do is we're going to take these middle feet and we're going to slide them onto the rail. Now you'll see the picture showing the feet going onto the rail and where they're positioned. You're doing 2 feet per rail. But the picture afterwards will also show that profile of how the foot is actually going onto the rail and showing you tightening them up when you've got them on location. If you've got the 12 by 30, these 2 rails will be quite short. Close to half the length that you see here. And so when you put the feet on, you're still going to space them evenly, just how the picture shows, but the proportions will just be different. So I'm just going to lift up the rail here, and I'm going to slide the foot on just like that. Whee! And I'm going to turn it on its side. I'm going to do the same for the other rail. And if you want to use a measuring tape for this, you can. If you don't care, that's fine too. I really don't care. I'm perfectly fine with, placing these roughly by eye. So it depends what kind of person you are. The exact placement will be, if you want to do the math, you can split up the length of the rail and divide it into thirds. But the placement of the feet isn't imperative to the operation of the machine. So, take that as you will. They're there to kind of support the machine's operation. So if you want to place them a little bit closer to the center to give it more support in the center, then that's fine too. And so notice once again, we've got the red tightening arrows here. And so that's what I'm doing, is I'm tightening them all the way down. These will be a bit harder to tighten down because you're using the long end of the Allen key instead of the short end, but just give them a nice solid twist all the way down so that you're confident that they're seated properly. And if you really need to, you can, for instance, take the wrench here, put it in the circular hole of the wrench, and you can give that a twist to get some extra leverage. But don't go too hard on it because, these are plastic feet. you're using a metal piece and another metal piece to bolt on a plastic thing. And so if you really ream down too hard, you can start deforming the plastic or even break it. And so you just, use caution. Great. And these should feel like really well attached now. I know it seems like it's just one bolt, but the way the feet are actually designed is they're how do I say? They're kind of subtly slanted inwards in how it matches the rail profile, so that when the bolt gets tightened, not only does it align it so it stops it from twisting, but it also actually squeezes in those edges into the aluminum profile, which really gets the foot hugging the rail nice and tight. And so these, they shouldn't really go anywhere. So I kind of already explained this. We're at the intermission, but I already kind of explained this. We're going to be putting together both sides of the machine. The nice thing about the intermission is you can kind of view from your own angle how the following parts are going to go together. We're going to be using these two Y-Gantries that we put together and the feet. And the solid pieces in the picture are showing the parts that we already have, which are the rails with the feet, and the transparent ones are the ones we're going to add. It also mentions here mirror mode, which I think is a really cool term. And you can keep an eye out for that icon anywhere in the instructions, even though it's mostly just used in this one area, showing how every step that we show to you, you're going to then do mirrored for the other side. So here we go. I'm going to first just cut the tape for the feet here so that I can unwrap them. That way I'll have them prepared when I start putting everything else together. Excellente. So start with whatever side you want. I'm going to start with the left side here, but you can use the right side as pictured as well. And just look at the picture beneath where the gantry is sliding on, and that'll give you an idea of the profile of the rail, which you can see when you look down at it, as well as how the profile of the wheels fits onto that edge. So you should find that these slide on with some extra wiggle to them, and that's because as we did previously, we opened up those offset nuts in order to make sure that they are spaced further away. If it is a little bit tight starting out, sometimes that's possible, and so don't panic or be alarmed or anything like that. Just double check that your nuts are all the way wide, and if they are, then that's fine. Having them tight right off the bat is just fine in terms of the machine operation, because it actually gives you more space to close them over time as the wheels wear out. And now I'm just going to be putting the feet on the ends. So when you're doing this part of the assembly, just make sure that I'm going to dig into my same bag of M525 bolts. And just make sure that when you do this assembly, you're doing it on a relatively flat surface so that the bottoms of the metal feet and the bottoms of the plastic feet can all line up. I'm just going to be doing this on the MDF, as you can see. If you're doing it on an MDF or other table surface, that's fine too. And these are going to be another set of bolts that will take a little longer to put in, but we really wanted to make sure that the feet and the rail could be very securely attached to each other by giving a lot of thread length for the bolt to grab onto. You'd be surprised actually that because of how aluminum is, it can sometimes be a little on the soft side, and the threading can kind of cross thread or wear out. That's something actually you want to be mindful of when you're putting these bolts on. If it feels a little tricky to put on, it probably means that you haven't aligned the bolt up correctly. So just screw it back out and make sure that the bolt looks relatively straight, not just when you're looking down at it, but also from the side, to make sure that it's going in correctly. Because when you're screwing these on, it should feel quite easy to rotate the Allen key. I'm giving you guys a moment of silence here so you can remember what it's like to not hear my voice. Another thing that I'll mention again is, since we're doing these bolts as kind of a 2-bolt pair for each foot, you're just going to want to go between the two when you're tightening them down. That way you can make sure nothing's twisted out of the way and it's all kept relatively aligned. I know in the instructions it shows putting on the front and back feet of one rail first and then, mirroring that to the other foot. You can do it this way too. Because these are the sides that are closest to me right now, it's the most easy to access them. And then I'm just going to turn them both around and put the foot on the other side at the same time as well. Pretty nifty. If you haven't figured out quite yet, or if you haven't yet figured out the placement of these feet, the images below do show a transparent version of the foot, so you can see how there's those green crosshairs that you can see. And that's trying to point out to you that those are the bolt locations. You might have to do a little bit of finagling when you're trying to put these in, just to get the threading started. But once you get it started, it should be smooth sailing the rest of the way. I've just now realized that one of my plastic feet is pretty close to the edge and the other one's pretty close to the middle, so have fun staring at that the rest of the video. While I'm tightening this on, I'll point something else out, which is that it's very barely noticeable, but these feet actually have a tiny little notch in the top of them. And we're going to use this at a later stage when we're actually mounting the machine down to its work surface. And that will allow us to check the squareness of the diagonals in order to make sure that the machine is being mounted square so that you get square cuts. Actually, you know what I might do is I might actually assemble this machine facing you guys rather than facing me, because it might clear up some of these extra steps. Well, not extra steps, the following steps. Just doing the final alternating between the two. Once again, you don't really gotta go too hard on these. Okay, well, let's swap these real quick. Ta-da! Got your two machine sides here. Grab your cold beverage and just kind of sit back and look at it while you take a sip. Okay. This last part is going to feel very familiar. I'm going to actually do it on one of the rails first, completely, from start to finish, and then I'm going to do it on the other rail. And that way I can kind of just have one of them out of the way, and you guys can focus on what I'm doing. Actually, I'll do it on the right side one, because that one is what is shown in the footage, or the written manual. So, this setup, as I mentioned previously, is going to be set up very similar to how you assembled your XZ gantry assembly. You're going to be using the lead screw with the coupler on one end, which would be this end actually, or sorry, this end, yeah, and then the nut on the other side, and the flange bearings to support the lead screw on both sides. And what that's going to do is it's going to create what I like to call a component lead screw sandwich, where you're kind of bringing it all together, constraining it between the 2 feet, and it's going to all be nice and tight, but it's still going to spin nice and easily. So the first step to that is you're going to grab one of the lead screws. For the 12x30, this will be the shorter lead screw, or the medium length one, but these will be the shorter ones that are left in the pile. And basically what you're going to be doing is you're going to be coming in. As I said, I'm doing this kind of mirrored to you guys. You're going to be coming in the back side, and then you're going to have to look out for the anti-backlash nut and thread that in from the back side. You can see in the picture there's that blue arrow showing that you're rotating this into place. Now, because we're not sadists, we're not going to get you to put this all the way on. Just put it a little ways on, and once you got enough stick out, it'll work for you on the other side here. If you want to do this mirrored on the other side right now, feel free. I'm just going to continue on, as I said, to show the whole process. So now you've got the bearings. We're going to grab 2 of them again. And we're going to put them on either side. Just on the feet, these are a little bit of a tighter fit. And then you'll push through the lead screw on the one side, and you put the bearing on the other side through the lead screw. If these are a little tight, which they may be, that's fine. You just have to give it a little wiggle and a little wobble. And in a worst case scenario, you can carefully tap this on with a mallet or something like that, but usually it's not necessary. So now, before I move on, you can see on that bearing diagram how it shows this is the back foot and this is the front foot, right? So in this case, because I'm kind of mirrored to you guys, you can see how this is the back foot, because I'm trying to like face it towards you, but you know what I mean. And this is the front foot here. So when we move forward, you can see how the back foot is the one that's going to receive the coupler, which I've still got the bags of coupler, or the bag of the couplers here. And the front foot is going to be the one that receives the brass nut that we put together. And so using the smaller Allen key, the M3 Allen key, I'm going to put on the coupler first on the back side foot, and we're just going to make sure, once again, this goes on all the way. Oops. And then tighten just the one screw, the one that is on the same side as the lead screw. This part you can really snug up because you want the coupler to really hold on to the lead screw nice and tight. And now from the other side, I put on the brass nut. Here, I'll slide it forward for the close-up cam. Sometimes these brass nuts can be a little finicky to get on, but as I said, once you get started, they'll feel good. Now the only difference here versus the previous assembly is that before you were kind of twisting the coupler and the nut against, or in opposite directions with your hands, but in this case the coupler is, all the way over there. So instead what we're going to be doing is we're going to be twisting the lead screw with one hand and the nut with the other hand. If you scroll down, you can kind of see a picture of my general strategy on how to do this. I put the Allen key into the set screw, and I use that as a proxy to turn the brass nut in the one direction while I turn the lead screw in the other direction. And then while they're both being turned, that's when I go and I tighten the set screw down. So if you want, with your fingers, you can go and tighten down the set screw most of the way. And then I'm going to turn them against each other as tightly as I can. And while I'm turning them against each other, I'm going to try to twist this set screw into place. And just like the coupler, this one you really want to tighten down nice and snug so that it's not going anywhere. Okay, and the way you can confirm you've done this all correctly is you should now be able to put your fingers on the lead screw and go to, shake it back and forth, and you shouldn't feel any motion. It should be solid. But then when you go to twist it, obviously it should twist very freely. This is very similar to how we did before. So if you were doing this mirrored the whole time, congrats, you're done this section. I wasn't, so I'm just going to quickly do the other side too. way, if you haven't noticed it yet, a new feature I added to our resources is that any picture you want to see slightly in slightly more detail, you can actually click and hold your mouse over it, and it'll zoom up a little bit for you. So if you need to see any better detail on how this is all going together, feel free to use that feature. Tighten the coupler down. And by the way, guys, please remember, you only tighten down the one side of the coupler. Don't tighten down the other side. The other side we're going to tighten down when we attach the motors. And if you tighten it down now instead of later, it has the chance to damage the coupler, which is no good. We do have a trick that I might show you in this video on how to repair the damage to the coupler, but it just leaves you with more things to worry about. So it's better to just do it right the first time. Okay. On to the next page. Now, I call this page Axes Completion, and that's because this is where kind of the rest of the main mechanics of the machine are going to come together. It's really cool how quickly it happens. I'm going to, as I said, I promised, I'm going to face this towards you guys, even though it'll make it a little bit more finicky for me. But at the very least, it'll give you guys a better view of